In this video, let's look at the area between two curves. We have used the integral thus far to represent the area between a curve and the x-axis. Now let's discuss how to find the area between two curves on a coordinate plane. Sometimes the curves will intersect, and sometimes the area will be defined as being between two vertical or horizontal lines. And we'll talk about the horizontal lines a little bit later. If f of x and g of x are continuous on the interval from a to b, and f of x is greater than or equal to g of x, then the area between the two functions is the integral between a and b of f of x minus g of x dx. So if I've got my f of x function, this blue line, and my g of x function, the green line, if I wanted to find the area between the curves, I'd find the area under the f of x curve, then find the area under the g of x curve, and then I would just subtract the two, and I would be left with the area in between the two curves. So this is a representative rectangle whose height is f of x minus g of x, and the base is delta x, or dx. So the shaded region here is given by the integral from a to b of f of x minus g of x dx, where f of x is above g of x. So here's our first example. Find the area of the region bounded by y equals negative x, and so that's this guy here, and a quadratic x squared plus 2, this guy here. So we can see that the quadratic is above the linear function, and it's giving us some boundaries between an x value of 0 and an x value of 1. So we don't need to find intersection points because we have the boundaries. We'll set up our integral between 0 and 1 of the top function minus the bottom function. Now I'm going to go ahead and clean this up just a bit before I end a differentiate. So this isn't too bad. It's going to be x cubed over 3 plus x squared over 2 plus 2x. And I'm going to evaluate that between 1 and 0. If I substitute in the 1, I'll have 1/3 plus 1/2 plus 2. And if I substitute in the 0, I'm just going to have 0. So I'll just put a little representative 0 to the right. Let's go ahead and find a common denominator. This will be 6. So 1/3 will be 2/6. 1/2 will be 3/6. And 2 will be 12/6. If I add those together, that's going to give me 17/6. And that's going to be the area between those two curves in the boundary 0 to 1. In this example, the boundary lines were given as equations of vertical lines since the two graphs did not intersect. In many cases, though, the graphs will intersect. So first, we'll need to calculate the intersection points. And to do that, let's go ahead and set our equations equal and then solve. So my f of x function equal my g of x function. If I move everything to the right, I'll have x squared plus x minus 2 equal to 0, and I'll just need to factor this. I use my bottoms up method, so I multiply the first and the last number, and I need to find two numbers that have a product of negative 2 and that add to get 1. And so that's going to be 2 and negative 1. My factors are going to be x plus 2, x minus 1, and if I solve each of these, this is the zero product property, x will be negative 2 or x will be positive 1. I'm going to go ahead and mark those on my graph just so I've got them. I've got an x value of negative 2 and an x value of positive 1. Those are my intersections. All right, so that was your first step. Second step now is to write the integral. And so my boundaries are negative 2 and 1, and my top function is the quadratic, so that's 2 minus x squared, and I will be subtracting the bottom function. All right, let's differentiate. And evaluate between 1 and negative 2. If I substitute in 1, I'll have 2 minus 1/3 minus 1/2. And then if I substitute in negative 2, let's see, I'm just going to go ahead and write it all out so I don't make as many mistakes. Okay, let's clean this up just a bit. All right, so I'm going to have 2 times negative 2. That's going to give me a negative 4. And if I distribute the negative, that'll give me a plus 4. All right, in this next term, negative 2 cubed is going to give me negative 8. That will make a positive 8, but if I distribute this minus sign, that'll give me negative 8/3. And in my last term, let's see, negative 2 squared is a positive 4 over 2. So that's positive 2. The minus sign will make it negative 2, but then if I distribute the negative to that, that'll make that positive 2. Okay, so let's see. If I combine the negative 1/3 and the negative 8/3, that'll give me negative 9/3, which is negative 3. And let's see, so I'll just have negative 3, and let's go ahead and combine the 2 and the 4 and the 2, so that'll give me 8 minus a half. And so let's see, 8 minus 3.5 is going to give me 4.5. Okay, here's another example. This time we have a cubic function and a quadratic. And it says, remember, you always must subtract the bottom function from the top function. This graph must be split into 2 integrals because g of x is the top function to the left of 0 and f of x is the top function to the right of 0. And notice we don't have any boundaries, so we need to go ahead and solve for those. Let's set our 2 equations equal and solve. All right, so if I move everything to the right, this will give me 0 is equal to 2x cubed. My square terms will cancel, and if I subtract the 3x, that'll give me minus 8x. I can factor out a GCF, a 2x, and I'll be left with x squared minus 4. If I write this in factored form, I've got 0 is equal to 2x times x minus 2, x plus 2. And if I solve each of these, I'm going to have 0, 2, and negative 2. So on my graph, I know the intersection down here is going to be at an x value of negative 2. Of course, I'm intersecting at the origin, and an intersection at positive 2 right here. All right, so let's write our integrals. So my first integral is going to be from negative 2 to 0. And the cubic function's on top, so 2x cubed minus x squared minus 5x minus the quadratic. All right, and then I'm going to add that to the integral from 0 to 2. This time the quadratic's on top minus the cubic. All right, I'm going to go ahead and clean up just a little bit. And I think I need to have another set of parentheses over here. So then that's going to be plus x squared plus 5x dx. And let's see, was there anything over here I could cancel? Yes, I can cancel these two and combine those like terms. So I'll end up with negative 2x cubed plus 8x dx for this integral. All right, let me go ahead and clean off some space so that I can evaluate. Okay, so if I differentiate this first, oh, you know what, let me go ahead and clean up that first term. This is going to be from negative 2 to 0 and 2x cubed. These terms will cancel, minus 8x dx. There we go. Now let's differentiate. So this will be 2x to the 4 over 4 minus 8x squared over 2. And that's going to be evaluated between negative 2 and 0. And let's just go ahead and work that. So that's going to give me x to the 4 over 2 minus 4x squared, evaluated from -2 to 0. So if I substitute in a 0, that's just going to give me 0. If I substitute in the -2, that'll give me -2 to the 4th over 2 minus 4 times -2 squared. All right, so that's the first one, and I'll clean that up just a bit. Okay, let's take a look at the second integral. So this is going to be, let's see, -2x to the 4th over 4 plus 8x squared over 2, and evaluated between 0 and 2. So if I clean this up just a bit, that's going to give me -x to the 4th over 2 plus 4x squared, evaluated from 2 to 0. And remember, we're going to be adding these two integrals together, so I'll just put a plus sign right here. If I substitute in the 2, let's see, that's going to give me -2 to the 4th over 2 plus 4 times 2 squared. And then if I substitute in the 0, it's all going to be 0. So I'll just put the little 0 over there. Okay, so I'm still going here. Let's see if we can clean up these fractions. So let's see, I'm going to have a negative, and then -2 to the 4th. So that's going to give me 16 over 2, which is 8. And -2 squared is 4 times 4 is 16. All right, in the second one, let's see, I've got 2 to the 4th is 16. That's going to be -16 over 2, which is -8. And then 2 to the 4th, so this is going to be 16. And minus 0 will go away. All right, so this is going to be -8 plus 8. So this is going to be 8 plus 8. Final answer, 16. All right, we've got another example here. It says find the area bounded by x equals y squared and x equals y plus 2. It says this time your rectangles will be horizontal, which means that the width of the rectangle is now dy. Let's go ahead and draw in a representative rectangle. It's going to look something like this. Okay, so this width right here is dy. Rectangles will go horizontally because this time the bottom function is going to be x equals y squared, which is this curve right here. And when we say the bottom function, I mean the left function if we're going horizontally. And then the right function will be the linear function, x equals y plus 2. All right, so if we have horizontal rectangles, we need to integrate with respect to y. And so our boundaries are going to be y values. So let's go ahead and solve for those y values. All right, so let's set our equations equal. So y squared is equal to y plus 2. If I move everything over and I factor this, and I use my little t-chart, so I need two numbers that multiply to get -2 and add to get -1. So this is going to be -2 and 1. And if I solve for each of these, y is going to give me 2, and y is going to give me -1. And so let me go ahead and mark those. This is going to be a y value of 2, and this down here will be a y value of 1. Now I can find those coordinates by subbing in those y values. So if I do that, I've got x is equal to, well, the y squared, and so the x value is going to be 4. So this point here is going to give you 2, 4. And the point on the bottom, x is equal to y squared, so -1 squared, and so that's going to give you x is equal to 1. And so let me make sure I wrote that right. X is equal to, oh, yep, I didn't. I need to switch these. I knew that was wrong. 4, 2. How about that? All right, and this guy is going to give me 1, -1. All right, those are my two intersection points. So let's set up our integral. So this time my integral is going to be between -1 and 2, and I need the rightmost function first. And so that's the linear function. That's going to be y plus 2, and I'm going to subtract the quadratic, the horizontal parabola. So that's going to be minus y squared dy. All right, I can leave it like that. Doesn't really matter, but I need to integrate. So this is going to give me y squared over 2 plus 2y minus y cubed over 3, and I'm going to evaluate from -1 to 2. Let's substitute in the 2, so that's going to give me 2 squared over 2 plus 2 times 2 minus 2 cubed over 3, and then I'm going to subtract, substituting in the -1, so that's going to give me -1 squared over 2 plus 2 times -1 minus -1 cubed over 3. All right, let's clean this up. So 2 squared over 2, that's going to be 4 over 2, which is 2, plus 4, minus 2 cubed is 8, so minus 8/3, minus, and then -1 squared is 1, so that's going to give me 1/2, plus 2, and then -1 cubed is going to give me, what, -1, so that's plus 1/3, and then we'll distribute the negative, so that's minus 1/3. Okay, I think I have all my numbers right. Let me just double check. Plus 2, yes. All right, let's clean this up. Again, we've got that -8/3 and 1/3 combo, so that's going to give me 9/3, which is -3. And 2 and 4 make 6, 7, 8. So 8 minus 3 is 5 minus 1/2 is 4.5. Final answer. Okay, could we have integrated the previous problem with respect to x? Yes. The problem is that the bottom function changes. Okay, so what we're looking at, if we do this with respect to x, the bottom function here is the quadratic, and then on to the right of that, the bottom function is the linear. So let's go ahead and write our intersection points on here again. Let's see, what were they? 4, 2, and 1, -1. So this is going to be, oops, let me get my pen back. Okay, so if I'm going to do vertical rectangles, we can see that over here I've got this positive square root on top of the negative square root. So let me go ahead and write down our two functions. If we recall, we have x is equal to y squared, and x is equal to y plus 2. So this time let's solve for y. All right, so if I solve for y, I've got a square root. So y is equal to plus or minus the square root of x if I take the square root on both sides. Okay, and so for part of the function, I'm going to have the positive square root of x and then minus the negative square root of x. That's what's going to happen over here. And then if I solve for y over here, that's just going to give me, well, y is equal to x minus 2. So that one's easy. Okay, let's write our integrals. So the first integral is going to be from, well, 0 to 1. 0 is the origin up to an x value of 1, and I'm going to have the positive square root minus the negative square root. So this is going to be square root of x minus the negative square root of x dx. And I'm going to add that to the integral from, well, 1 to 4. And let's see, my top function is going to be the positive square root of x minus the linear function and dx. Okay, we just need to differentiate and then evaluate. So let's do it. And this is going to be, well, 2 square root of x dx, if I just clean this up a bit. And let's see, what about this guy? Square root of x minus x plus 2 dx. And 2x, let's see, add 1, that's going to be 3/2 divided by 3/2, so I'll be multiplying by 2/3. And evaluate that between 1 and 0. So let's see, that's just going to give me, well, 4/3, right? Oh, thankfully. That looks a lot worse than it was. And this is going to be let's see, x to the 3/2 over 3/2, so times 2/3, minus x squared over 2 plus 2x, and this is going to be evaluated from 1 to 4. Okay, so if I sub in the 4, I've got 2 times 4 to the 3/2 over 3, minus 4 squared over 2 plus 2 times 4, minus, and now let's sub in a 1. So that's 2/3 minus 1/2 plus 2. Okay, I'm going to clean up a little space so I can do some calculations. Okay, so I still have the 4/3 plus. Okay, so this 4 to the 3/2. All right, if I take the square root of 4, that's 2, and if I cube it, that's 8. 8 times 2 is 16, so that's going to give me 16/3. All right, so now let's take this next term. 4 square root of 16 over 2, that's going to give me a minus 8. Okay, and then we have plus 8, and then I have no idea. So let's see, I'm going to need a common denominator. So that's going to give me 4/6 minus 3/6 plus 12/6, I believe. So 4/6 minus 3/6 is 1/6 plus 12/6 is 13/6. And that's minus. Okay, so let's see, my 8's cancel, and 4/3 plus 16/3 is going to give me 20/3 minus 13/6. So let's see, I can go ahead and double that, 46 minus 13/6, and 27/6. And so let's see if I did this right. 6 goes into 27 4 times with 3 left over. 6 into 30 is 5 times, and so 4.5, and that's my answer. Hey, that's the same answer that we got before, 4.5. So yes, we did it right. Okay, one more example for you to try. Find the area between x equals 3 minus y squared and x equals y plus 1. Do this with respect to x, then with respect to y. Okay, so with respect to x, I need to solve for y. Because with respect to x, I'm going to have rectangles that look like this. The base is going to be dx. So I'm going to need to rewrite these equations. So if I have x is equal to 3 minus y squared, x minus 3 is equal to negative y squared, and let's see, y squared is equal to negative x plus 3, and if I take the square root, y is equal to plus or minus 3 minus x. I'm going to write it like that. Okay, and then if I solve for y in the second equation, y is equal to x minus 1. Okay, so we need to find the intersections. So let's do that next. So let's see, 3 minus y squared is equal to y plus 1. And move everything to the right. So I have y squared plus y, and if I subtract 3, 1 minus 3 is negative 2. Okay, factor this. Two numbers that multiply to get -2 and add to 1. That's going to be 2 and -1. Solve each of these. So y is equal to -2 and y is equal to +1. If I write that on my, here's my +1 and here's my -2. Let's go ahead and find the corresponding x values for each of those y's. So that'll be my next step. If my y is -2, x is going to be a -2 plus 1, so my x is going to be -1. This point right here is going to give me -1, -2. If my y value is 1, then my x value is going to be 2. So this point here, whoops, this is going to give me 2, 1. All right, so now I can go ahead and write my integrals. All right, so my first integral, and let's see, what else is going on here? Because if I'm going to do this with vertical, I've got this piece from a -1 to 2 where the linear is on top of the quadratic. And then I've got a piece from 2 to, well, 3. If I know my transformations here, this is going to be shifted to the right 3. If I factor out a negative, and that's going to be x minus 3, and so that's a horizontal translation, right 3. So I know that this is going to intersect the x-axis at +3. So I need to know that because I'm going to have two separate integrals. I'm going to have this one where the linear is on top of the quadratic from -1 to 2, and then from 2 to 3, I've got the positive quadratic on top of the negative quadratic. And so let's go ahead and write these integrals. So from -1 to 2 of the linear, and these are verticals, so solve for y. And let's see, this is going to be the negative quadratic. And then I'm going to add it to the integral from 2 to 3. This time the positive quadratic minus the negative quadratic. Okay, so let me just clean this up one bit. And not a whole lot to clean up. Okay, I'm going to actually show you how to plug this into your calculator, because that's quite a bit of algebra. So let's go to Desmos. All right, and so here's what we're going to do. You're going to type in int, integral, and then our first boundary was going to be from -1 to 2. Lots of parentheses. So this is going to be x minus 1 minus, and then negative square root of 3 minus x dx plus the integral from 2 to 3, parentheses, square root of 3 minus x minus, I guess I could put a plus a negative square root of 3 minus x dx. I think I have it all in there right, and the answer is 4.5. Actually, I had worked it out on the top row just in case I made a mistake. I practiced. I didn't use the parentheses the same exact way, nor did I clean up those minus signs, but still, it's going to give you the right answer. All right, last thing, let's just set up the integral with respect to the y-axis. So then let's go back to this guy, and I'm just going to erase and do it on this one since I've got all my values and everything on that graph. We know the answer is 4.5, no matter what. Let's just set up the integral. So this time, our integral, if I do horizontal rectangles, this would actually be easier because our right function is always the quadratic. Our leftmost function is the linear. So we're just going to have 1 this time. So that's nice. That'll make it easier. So our y value is going to be from, whoops, use a pen, -2 to +1, and this is going to be the quadratic, and so solve for x. So it's going to be 3 minus y squared minus the linear dy. And if you want, go ahead and go to Desmos, calculate that out. You should get 4.5. All right, guys, if you have any questions, please ask either in buff time or on Remind or in class.